Hey YouTube, this is the basics of calculus, and this is part 1. Okay, the first thing you need to learn in calculus are rational functions. And basically, rational functions fall under the basic format of fx equals px over qx. Fx pretty much stands for a function, okay? So, yeah. Your goal as a calculus student is to be able to look at a problem and find where the exceptions or limits, also known as vertical asymptotes, are. So, a limit is essentially an area a graph cannot cross, and that basically tells you the range that your graph can go through, okay? So, like, a limit is like a roadblock. You can't cross it. It's there, but you can't cross it, okay? So, let's look at the function x squared minus 5 over x plus 3, okay? How do you find the vertical asymptote, you ask? Simple. Make the bottom equal 0. Okay, as you can tell, there's not two answers here because it's not x squared, it's just x. So what you do is x plus 3 equals 0, and that yields x minus 3. What does that tell you? This graph has a vertical asymptote at x minus 3, okay? So the function, or the range actually, of the function is all real numbers with exception of -3, because -3 isn't part of the range, it's not part of the graph, okay? So all real numbers are all the numbers, decimals included, except a rational and a negative number, okay? A rational negative number can just not exist. A radical with a negative inside, because a root cannot rationally exist with a negative inside, does not exist. Therefore, it is not a rational number. Everything else is a rational number, decimals included, okay? So, for example, -1, -1,000,000, 100, -100, 1,000, infinity, they're all rational numbers because they all do exist, okay? So, the only way a number isn't rational is if it's a negative with an irrational sign. For example, radical -7 does not exist. It is not a rational number, okay? So, now that we're clear. So, as you can tell, our range before was all real numbers, -3. All real numbers is represented by r, and then you put a little line, and then within brackets you put -3 because -3 is not included into the graph, okay? And this is how you graph it. This is a graph, and the vertical asymptote is basically a line down -3, okay? So the graph can go through here, it can go through here, but it can never touch -3, which is why -3 is a limit, or a vertical asymptote, okay? So a vertical asymptote at -3, this means that the function can never touch -3 from the left or from the right, because it is a limit to the function, alright? So step 2. Substitute the exception to function as graph approaches from the left, and do the same as x approaches from the right, alright? So basically, you have to do step 2 twice. First from the left, and then from the right. So let's start from the left, shall we? X, line, -3. And this symbol here on top of -3 is a negative sign, which means it approaches from the left, alright? So we're working with the left. So replace -3 into the top and bottom part of the function wherever you see an x, alright? So here, where there was an x squared minus 5 over x plus 3, it would equal -3 squared minus 5 over -3 plus 3. When that happens, you get 4 over 0, alright? Because the bottom will always equal 0. Okay, well, now what you have to do is that you have to determine whether the 0 is positive or negative. Okay, since we're working with the left now, you have to get a number that's to the left, directly to the left of -3. Obviously, that would be -4, okay? So you replace the number that you got into the denominator. -4 plus 3. That equals -1. Because the number of the denominator is now negative, that tells you that the 0 is negative, okay? So that means as x approaches from the left, it'll go down. So the graph here goes down, because from the left it's negative. So what you do is you would draw a little arrow going down as an indicative. Now, you have to determine whether the 0 is positive or negative by taking a number directly to the left of the vertical asymptote, -3, in this case. Let's say negative 4 is substituted in the bottom, which is what we did. Because the value is negative to the left of the equation, the 0 on the bottom will be negative. Okay? Division by 0 is always undefined, hence a number over 0 equals infinity or negative infinity. And because 0 is negative in this case, as x approaches from the left, it's negative infinity. Okay? So it'll look like this. Negative infinity. Okay, now we have to do what we did for the left to the right. So x, negative 3 to the right, and a number directly to the right of negative 3 would be negative 2. So you put negative 2 into the denominator. Negative 2 plus 3 is 1. Okay, so 1 is positive, which means it's a positive 0, and that yields positive infinity. So 0, x from the right infinitely goes upward because it's positive, okay? Substitute negative 3 in top and bottom again, find out the value of 0. Okay. Then you did pretty much what we did here, and yeah, and it's positive. So this is what the graph would look like. From the left, it's negative, and from the right, it's positive, okay, of the vertical asymptote. So negative infinity, positive infinity, okay? The graph will never touch negative 3 because negative 3 is an asymptote. And the range of the domain is all real numbers except negative 3, right? Well, YouTube, that is example number 1 for rational functions.